Let's go, everybody. You did a good job on the intro to this yesterday. Now we're just going to set you up for success on our assignment today. Here we go. We're solving problems that involve proportional relationships. So you can just assume that everything in here is a proportional relationship today. And therefore, if it's proportional, we can set up equivalent ratios. We call this a proportion, and it's used to help us solve proportional relationship problems. So let's get after it. Let's read it. A 6-ounce package of fruit snacks contains 45 pieces. Well, that looks like a ratio to me. It looks like we're comparing the number of ounces in a package to the number of pieces in a package. Always label those because we want to keep everything organized. Make sure we put the numbers in the right spots. That's the labels help us with that. So we have 6 ounces would be 45 pieces. So then we have to go over here and we're going to again have to compare in the same order, in the same position, a certain number of ounces to a certain number of pieces. Well, they say how many pieces, so I know that's my X. And it said, would you expect in a 10-ounce package? So that's going to be 10 ounces right there. And then we get to solve the proportion. Now, we can solve the proportion in a variety of ways, but the foolproof method, though if you learn this, you'll always be able to do it, is to cross multiply. So we know that cross products are always going to be equal. So we would get 6x equals 45 times 10, which is going to be 450. It ends up being you just multiply these guys and then divide by the one that's kind of next to the x or across diagonal from the x. But we get that, and then we're going to divide by 6 to get that. So x equals, we're going to divide 450 by 6, which comes to 75. And then one thing that we try to do is to remember to read the question again. Okay, it says how many pieces? So that means our answer is going to be in pieces, right? So that means a 10-ounce bag of fruit snacks can contain 75 pieces. All right, let's go look at number 4. The key, sorry, I'm going to go back to this one. The key is that we are constantly lining up the units, the correct units. So, all right, wherever we put pieces, that has to be in the same position. If it's on the bottom over on the left, it has to be on the bottom over on the right. All right, we got to line them up. All right, let's go to that next one. Of the 50 students in the cafeteria, 7 have red hair. If there are 750 students in the school, predict the number of students who have red hair. So we're doing total students, right? So total students in our proportion and just the students with red hair. All right, that's the two quantities that we are relating. So it says 50 total students and 7 have red hair. So I'm going to have the red hair students up here. They're the total students down there. I'm just running out of space, so sorry. I didn't write the whole word out. But anyway, the question asks, if there are 750 students, so that's total students, so 750, then predict how many would have red hair, so that's what we're predicting. We don't know. So now we can cross multiply and divide. So we can multiply the numbers that are directly diagonal from each other. And then we're going to divide by this remaining number. So we're going to do 7 times 750, and that gets 5250. And then we're going to divide by that last guy there. And so we're going to divide that. So then 5250 divided by 50, and that gives us 105. And now we always go back and check out the question. It says predict the number of students who have red hair. So That 105 represents the students with red hair. Right? All right. There we go. Problem number 2 done in the books. Hopefully you're following along and doing well. You might want to just pause and try number 5 by yourself. I'm going to start it here. I should probably turn on my do not disturb, huh? There we go. The wait times for 2 different rides shown in the table. If there are 120 people in line for the swings, how long can you expect to wait to ride the ride? Now, this is tricky because there's so many numbers. There's extra numbers. Well, when I read it, I saw that they just were talking about the swings. So all we need to worry about is this ratio here. And we can kind of, we don't need that right now. Okay, so we're just focusing on the swings. It looks like we're comparing minutes to people in line. So how long it takes for a certain number of people in line. So let's get our proportion going. We're going to compare minutes to people in line. And that's going to be 12 minutes for 75 people. And then the question asks us if there are 200 people in line for the swings. So that's going to have to be people down here. $120. And then we've got how long will that take? So we're going to put the X up there. We're going to multiply the numbers that are across from each other like that, and that gets us 1400 and then 1440, I mean. And then when we we divide by that. So, oops, already got the answer. 1440, sorry, that was 12 times 120. And then we're going to take that and go 1440 divided by, oops, the remaining number, which is 75. And that gives us, and what we get there is 19.2. So that's going to be, we go back to the question that was asked. It says, how long can you predict this to wait for the ride? So our answer is going to be 19.2 minutes, right? Because that's what we're trying to find, how long it would take for that ride to happen. All right. Next one, Ingrid types 3 pages in the same amount of time that Tanya types 4.5 pages. If Ingrid and Tanya start typing at the same time and continue at their respective rates, how many pages will Tanya have typed when Ingrid has typed 11 pages? So it looks like we're comparing Ingrid to Tanya and how fast they can type. So if we were to put Ingrid's typing, how many pages she can type up top, then we'll put Tanya at the bottom. And it says Ingrid types 3 pages, so we'll put that there. At the same time, Tanya types 4.5 pages. So then it asks us the question. If they start typing at the same time, how many pages will Tanya have typed when Ingrid has typed 11? So where's that 11 going? Is it going up for Ingrid or down for Tanya? And if I read it again, how many pages will Tanya have typed when Ingrid has typed 11? So Ingrid is given, Tanya is unknown. And now we're ready to solve the problem. So we're going to multiply the ones there, 4.5 times 11, and that gives 49.5, and then we're going to divide by that remaining, and that's 49.5 divided by 3, and that gives us 16.5. Now we always go back and read through what they asked us about just to make sure how many pages will Tanya have typed. So this is, right, our answer is pages Tanya would have typed. And there you have it. We did it. We set up proportions to help us solve these proportional relationship problems. Great job. Hopefully you're getting the hang of it. Now you just have your lesson 1-6 extra practice to work on. Good luck. Miss you guys.